Mike Barley with Electric Lab. From our branch circuit wiring and switch control lab book, today we're going to go through the wiring diagrams D1 through D10 and go wire for wire with you on each conductor that is needed to do the core wiring scenarios in our book. So let's get started. Okay, so the first thing we have to deal with, of course, is grounding and bonding, and our equipment grounding conductor that will need to be run throughout the trainer. So equipment grounding conductor, the conductive path that provides a ground fault current path and connects normally non-current carrying metal parts of equipment together into the system grounded conductor or to the grounding electrode or both. So we're going to need to run grounding conductors through the entire trainer and connect all of the boxes together to create that path. Bonding means connected together. Everything is connected all together to create that effective ground fault current path. Grounding means connected to the earth. What we are doing essentially is bonding. So this is a diagram that's also included in the book itself, I believe, and these lines are giving you the indicators of how to run all of your green conductors throughout the trainer. Now you'll notice as it goes from the bottom left corner box up to the top and then goes in and out all the way across the top, drops a conductor down to each one of the light outlets, and then does the same thing across the bottom. But it doesn't connect in the far right vertical conduit. That's because you don't need to form a loop. You just simply need to connect them all together. So using this as an example, this is how everything should be connected together. Now, pigtails must also be added for connection to devices and to the metal box. So you're going to connect to the metal box via a ground clip, a ground screw. Perhaps you might be using ground pigtails. Those are great also. But nevertheless, you're going to have to bond to that metal box and then bring all of your grounding conductors together and then make pigtails in each box so you can connect to the device or whatever piece is going to be installed inside of that box. And the ground screws must be installed in all of the boxes. Now the light fixtures that are going to be installed on these trainers are typically, if you're using what we prescribe, is what's called a keyless light fixture. Those typically are porcelain or plastic fixtures, and they do not have ground conductors on them. So what I normally have my students do is simply bond the box on those octagon boxes, and really a pigtail for the connection to the light fixture is not required in this case because those fixtures don't have a ground screw on them. So some quick definitions to just establish what we're looking at here. A device, of course. A device is a term used to describe switches, receptacles, and similar components. The NEC definition states a unit of an electrical system other than a conductor that carries or controls electric energy as its principal function. And here we have a single pole switch. One of the things that I see students do a lot is, in the onset of it, is install these upside down. The big indicator for that is if you installed your switch upside down, it will say no instead of on. Then, of course, we have the three-way switch. Be mindful that this device has a common and two traveler terminals on it. This happens to be a Leviton brand. Not every brand has the exact same configuration, but all brands will have two brass screws for travelers and one black screw for the common. But they're not always in that same configuration. Sometimes the common screw might be on the right instead of the left. And I have at some points had different brands, a mix of brands of devices in my lab while doing these. And that has caused some confusion because students look at the drawing and think that's what I'm looking for. And when in reality, it might be on a different location. You just have to pay close attention. And of course, the four-way switch. A big reminder for wiring four-way switches, they wire top and bottom. You bring the two travelers coming in into the top. Maybe it's a red and a black, and then going out the bottom will be red and a black also. They do not feed side to side. And here are the keyless light fixtures. You know, these commonly were made in porcelain or out of porcelain. I think more commonly now you're seeing them in the plastic version, although you can still get porcelain ones. I remember installing the porcelain ones as an apprentice, and if you tighten them down too bad or too tight, they would actually they might hold for a few minutes, and you get down off the ladder and walk away, and all of a sudden you hear a big pop, and a part of the porcelain comes flying off of it. So be careful of tightening these down too tight. And of course, fasteners. You're going to use two types of fasteners on this trainer, the 632 by 1 inch and the 832 by 1.25 inches. The 632s are going to be for devices, and the 832s are going to be for your light fixtures. Now, you're using these outlet boxes, these 4-inch square boxes, and these 8B boxes, or octagon boxes as they're called also. And those boxes are not designed to have the devices installed and taken out and installed and taken out hundreds of times. They're designed to have a device installed in them, and then it stays there, you know, for the rest of whatever. So over time, the screw holes or the threads are going to wear out, and you may have to divert to different types of screws, maybe some tech screws, things like that. Those are not for permanent installation. That's because we're using these boxes, quite frankly, for not what they're being designed to be used for. You know, we're going to repetitively use them, putting stuff in and out, and you're going to wear out the terminals on them over time. Okay, so the first thing we're going to deal with in our wiring diagram here is going to be our grounding conductor. So we'll start here at the easy end with our light fixture. So we know that we do not have a ground conductor for the light fixture itself. We're going to just take it and simply connect it to the back of the box with our ground screw or ground pigtail or a ground clip. Next, over here in our single post switch, we're going to connect again to the box, and then we're going to come off of this and connect these together because all of our ground conductors have to be connected together. And then we'll bring an additional wire off of here and connect to the green screw on the switch. So that completes all of our grounding in this particular scenario. Now this is D1. This is a single post switch with the feed coming to the switch itself, and then what is called the switch loop coming out of it and going up to the light fixture. So you have a hot and a neutral coming into the box. You've got a hot and a neutral leaving the box and going up to the light fixture. So that's the basis of this scenario. Now, our next conductor is going to be the grounded conductor, or our neutral. Now, I'm going to use a yellow color because if I used white, you couldn't see it. But from our light fixture box, we'll start there, and we're going to connect that to the silver screw on the keyless light fixture. Now, at the switch, we have a neutral coming into the box. Neutrals do not connect to the switch, so we're going to simply feed that on through. We need that neutral at the light outlet to make the load work. So our neutral feeds on through, comes through the raceway cable, and then up to the light fixture, getting the neutral conductor or the grounded conductor to the box. Now, to deal with our hot conductors, we only have one left here in the light outlet box, so we're going to go ahead and connect it. Made a little double line there, but that's just one conductor. And then at our switch, we have power coming into the switch to the terminal here at the bottom section, and then we have power coming out of it and going up to the light. Now, the switch is the gate. So when you flip the switch up, power goes back out the other conductor, up to the light, completes the circuit, and turns the light on. And that is a single post switch controlling the light fixture. The power supply begins at the light outlet. So our next scenario, D2, is a bit different, and this is actually having the feed coming to the light rather than first to the switch. And this is oftentimes seen in the commercial application where you have conduits and feeder conductors coming through the above the ceiling, and the switch wiring going down to the switches on the walls would be dropped down from that point, and the actual power supply begins up in the ceiling or at the light rather than down at the switch. So again, first of all, we're going to deal with our grounding. Connect our ground conductors and connect it to the box there. And then we go over here to our light outlet. We have our feed coming in. That will symbolize our connecting to the metal box, and then we're going to connect around to the other ground conductor so it feeds down to the switch. And now we're going to do our neutral conductors next. Our neutral does not need to connect to the switch. It's going to be connected to the light. And of course I'm using yellow so it shows up on this white screen. And that's as far as your neutral needs to go. Then we're going to do our switch loop. In other words, our conductor that's going to connect to the terminal on the light. And then it's going to connect over here to our terminal on the switch. And then lastly, here's where we're going to need to connect the power supply, not to the light fixture, but we're going to connect it. I'll make a little jumper like that to get to the black wire. And then that feeds over to the switch. And that's where the hot wire connects to the switch. You flip the switch on, and then power goes back up through the red wire, connects to the light. Your neutral conductor is at the light, and your light fixture comes on. That is a single pole switch controlling a light fixture. The power supply begins at the light outlet. Now, here's D3. Now, D3 is adding in a duplex receptacle with a light outlet and a switch controlling the light outlet. The duplex receptacle is hot all the time. So, once again, let's do all our grounding. We'll start here at the easy end with our receptacle. Ground it. We also want to bring a ground conductor down, and we'll connect it to our green ground screw at the back of the box. And then our light fixture, we're going to always make that little pigtail there indicating I'm connecting to my metal box to bond it. No need to connect to the light fixture because the light fixture in this case is a keyless light and doesn't require a ground conductor. And then down at this end, we're going to connect to our box again, connect to our device, and then come down and connect to the ground conductor feeding into the box. Now what we're doing is when we make these little points where we have several wires coming off of it, we are creating a point that is going to be called a splice, where we have pigtails coming off of them, as they're termed as, and those conductors are extending out from beyond that splice. So that completes all of our grounding. Now let's do our neutrals. Notice how I'm doing these in a very systematic way, going through each conductor, and this is really how you should wire. There's ground conductors, neutrals, and then your hot conductors in a very systematic way. So now we're going to do our neutrals. So our neutral coming from the white wire there, connecting to the chrome terminal on the receptacle. Now in our light box, our neutral conductor will connect to the chrome terminal in the keyless light fixture. You can make a splice together with those and make a pigtail off of it and connect it to the light. A lot of the keyless light fixtures have two terminals on it, so you could bring one wire up to it and then another wire going to the second terminal and then goes off from it. Both of those are at the neutral terminal, so that's fine. And then on our end here where the neutral's coming into the box, we don't connect it to the switch because neutrals don't connect to switches. So that gets our neutrals done. Now, let's look at our switch wires. So we only have the switch wire going between the single pole and the light fixtures. So we're going to bring it on over, connect it to our light. And then in our switch, we're going to bring it over, connect it to the terminal on our switch. Now all we have left is our hot wires. So let's get those done. Down here at our receptacle, we have really one terminal left. We connect that. Now, here at the light fixture, we need to get a hot wire to go all the way to the receptacle. So we're going to feed this constant hot conductor all the way through. So it'll feed all the way through to the receptacle and make it hot all the time. Now back at our switch, we need to get a constant power supply to feed through the switch outlet and continue on so it gets a constant power supply to the receptacle. So we're going to draw that. And that comes through to this conductor. But we also have to get power to our switch, otherwise our light won't work. So we're going to connect from here, make a little jumper there, and then come to our terminal on the switch. And that completes our wiring for this. And this is a single pole switch controlling the light fixture and providing a constant power supply to the receptacle. The power supply on this one begins at the switch. Okay, now going next level here. This is D4. And this is our first set of three-way switches. It's three-way switches controlling the light fixture. The power supply begins at the switch outlet and the switch wire is at the opposite switch outlet. So this is, simpler terms would be, it's fed at one end and switched at the other. And in between those two three-way switches, you have what's called travelers. So you have traveler conductors that go between the brass terminals on the three-way switches that are transferring power back and forth to make this switching system work. So again, we'll start with our ground conductors. Quite simply, we'll get our ground wires done over here in the light box. We've got to ground our switch, ground our box here at this three-way switch, and then connect it down here. Get our box here on the end grounded. Okay, grounding's done. Now, neutral, we're going to have a neutral at the light. The neutral is shown feeding through both switch boxes. And that would be because either in the raceway or that's how it was designed, to where you had to bring the neutral all the way through it. If you're using cables like MC cable or NM cable, Romex, you're going to have all those conductors inside of that sheath, and then you got to deal with whatever's in those sheaths as they come in and out of the box to connect them properly to make the circuit work. So we're going to just connect our neutrals that feed straight through here and straight through here because they do not connect to switches. Now let's get to our traveler conductors. So I'm going to do the red first. The red conductor connects to that terminal. And then the red conductor on this end connects to this terminal. And then I'm going to very quickly switch to black. And then the other traveler connects to that brass terminal, and then this traveler connects to that brass terminal. That is our two travelers that run in between the two three-way switches. And we only have, three conductors left. So over here at the light, we only got one left to connect, and that's our switch loop that's coming from the switch itself going up to the light. And then down at this end, our switch loop always connects to the the common terminal on the three-way switch, typically the black screw. And then on the opposite end of this three-way switch, the black wire connects to the black terminal on the black screw at the opposite end. So this is fed at one end and switched at the other. Now I have used red conductors and black conductors on this. If you are pulling in pipe, as long as you are using a current carrying color conductor, you could use whatever colors you wanted to use. I just chose these. This is typically what you would see inside of an NM cable or MC cable, something like that. And as we're connecting these conductors here, you can tell I'm just using a pen and drawing in between point to point. These are terminals or even splices using wire nuts or something to that effect to make these terminations. You can use this diagram to take to the lab and then wire this scenario on your circuit trainer. Okay, now we've got D5. So changing it up again here a little bit. This is 2 3-way switches just like the last one, only now again we're moving the feed from the switch box. We're moving it to where it actually originates at the light fixture. So let's go ahead and get our grounding out of the way. Ground our box. Then complete it, connect it down to here. Come to our next outlet box. We have to connect those together. Ground our box. Connect it to the ground terminal on the switch. And then lastly down here at our far end switch, connect those to the box and then connect it to the switch. Now let's deal with neutrals or grounded conductors. Neutrals coming into here to the light fixture, it has to connect to the light. But we have a neutral colored conductor here feeding to the switches. If you're in one of the newer versions of our book, I believe this conductor may be in blue. But this could be a scenario where you have a conductor that's going from the switch up to the light, that perhaps it's just a 2-wire, so it has a black, white, and a ground. So at this point, this conductor that is white is going to end up being used as a current carrying conductor. So let's break it down from the far end here, and we'll work our way up to that. So first of all, we're going to connect our traveler conductors. So our red is first, and our red is connected down here. And I'm going to get over, we're going to start using a blue conductor and connect this blue up to here and that to there. Now my travelers are complete. So over here to the left, process of elimination, the only conductor I have left in here is the one that's going to be going to my common. So I've connected the black wire to the common on the 3-way switch on the left. Now, what have I got left here? I have a conductor that is feeding to the light. So I'm going to end up using my white wire and connecting that to the common on the 3-way on this end. Now, if you are to do that, this white wire has to be marked wherever it is visible. It needs to be marked black. I'm double marking it because it cannot be white, because you wouldn't want someone to get inside of that box and think this is a neutral when it's actually a hot wire. So it needs to be clearly marked black with a Sharpie or some type of permanent marking. So I know that's kind of sloppy on the screen there, but that's basically my point, is I wanted to show that that was not to be a white wire. And as I said, if you're using one of our newer books or PowerPoint versions, I believe this conductor is actually shown in blue, so don't let that confuse you. So our last conductor to connect here is our black wire, which from our feed in the light box, you don't want to connect that feed to the light or it's just going to burn hot all the time. So we connect it together with the hot. It comes over here to the next box, connects to the hot wire in this box. And then, as you can see, it passes it all the way to the end, taking the hot to the common on the 3-way at the end, and then the switch loop going to the light connects to the common on the other 3-way. At the end of the day, however you wire these, whichever scenario, the switch loop is always at one end of the 3-way, and the hot is at the other. And both of those are going to be on the common screws. And then you have travelers running in between. All right, next, D6. We're over halfway there. Now, taking it up a notch. So now we're going to have two three-way switches fed at one end and switched at the other. But this time, we've added in a four-way switch. Now, why would you have three switches? Let's say you have a room that has three doors where you could enter that room. You want to be able to turn the lights on and off at any of those three doors. That's where you would get this. When you're doing three-way switches and four-way switches, you could have as many four-way switches as you want in between there. You could have 50 four-way switches if you had that many doors in the room. This system will still work. What the four-way switch does is quite simply it is transferring the travelers back and forth inside of it to make this system switch no matter which switch you hit to turn the lights on or off. So again, let's get our grounding out of the way here. So we connect our ground to the box and our light. We're going to connect it to our switch, get our box bonded here, keep the grounded conductor moving on through. And at any time, if you need to stop the video and look at something a little bit closer, feel free to do that. Okay, and that gets all of our grounding connected together. So next, we're going to do our grounded conductors, or our neutrals. And when I say that, I mean the grounded conductor is the neutral conductor. The grounding conductor is essentially the green wire, the ground wire. So, our neutrals. We're going to, whoops, don't have the right color there, sorry. Hang on. So we're going to connect our neutral to the neutral terminal in the light outlet. But you'll notice our neutral is coming all the way from the left here because the feed is coming from the very first switch. Neutrals don't connect to switches, so I'm connecting that to the neutral going out of the box. It comes into this one, back out of it, comes into this one, back out of it, and then feeds all the way up to our light, getting our neutral conductor to the light. Now, let's do our red conductors. We're going to connect our red traveler there, our red traveler on our four-way, and then our red traveler down here on this three-way. And I believe after that, I think we're all black conductors. So, let's break this down. At the far end here on our light outlet, we connect our, what is our switch loop, going up to the light outlet, to the brass terminal on the keyless light. And then in our switching, we have connecting this switch loop down here to our common. So now we have our switch loop connected to the common on this end. And then this black traveler has to connect over to that traveler screw. Now that three-way's done, our light outlet's done. I'm going to go all the way to the other end here and go to the three-way switch. So connecting our traveler on this end, well, there's our two travelers. Now our hot coming into the box, we have to get a hot to feed all this to make it work. So we're going to bring this around and connect it to the common on that end. So now that's done. Whoops, I missed one of my red wires down here. I'll catch that in the end. So now we're going to connect our travelers on the four-way switch. And notice how I'm doing this, because this is very important. The traveler on four-way switches feed from the top and the bottom. They do not feed from left to right or side to side. So the two traveler conductors, the red and the black, coming in from the top of the box are coming into the top terminals. Red on the left, black on the right. And then coming out the bottom, red on the left, black on the right. That's how you connect a four-way switch. The most common mistake made with four-way switches is mixing that up. And if you do that, and you go through and do the standard test for testing three-way switches, your switching will work intermittently. In other words, you flip through it from left to right, this switch, then the four-way switch, and then the three-way switch, and everything works, and then you go back to the top and you flip it and the light goes off and it doesn't come back on. That's when you know you've got a common and a traveler, or the travelers mixed up on your four-way switch. That's how you test those. So that is a three-way switches and a four-way switch controlling a light fixture fed at the switch wire at the opposite three-way switch. Okay, next we're going to be doing D7, and this one, the feed is coming to the light. It's a little bit of a take on the last one, but we're going to be bringing the power into the light outlet and then dropping travelers and commons down to each end. So let's get our grounding done first. Ground our box. Do the same thing at the other end here. Ground our box, ground our switch. And then our ground coming into our box here, where it originates from. Connect that. I'm going to bring this one down and around this way just to keep it out of the traffic of the others. Okay, so we got our grounding done. Now we're going to do our neutrals. You'll notice there are no white conductors going down to any of the switches. The neutral is only going to be going to one spot, and that's to the neutral terminal on the keyless light. Okay, so now we have, in this scenario, we're going to have red and blue travelers. So on this end, I've got my red traveler jumping down to that terminal. I've got my red traveler down at this end. I always try to make those little humps to jump over so you know I'm not connecting anything together there. It's jumping over the top of that. And then I'm going to connect here in the middle with my reds. Because you see, those travelers don't ever connect to anything else but the common screws on a three-way switch, or not the common screws, the traveler screws on a three-way switch, or the traveler screws on a four-way switch. I'm going to mess anybody up by saying that wrong. So, okay, now we're going to do our other travelers. Traveler on this end, blue. Traveler on that end, blue. And now we're going to bring this blue traveler on around and connect it. So now all of our travelers are complete. So now we got to figure out how we're going to make the rest of this work. So we're going to our black conductors. Well, obviously at each end you only have one choice left here on your three-way switches. Your black wire is going to connect to the commons on both ends. So that means that your common coming into the box here has to go to two places. First of all, we have our hot coming into it. So we're going to do a little jump through the middle here, come up to the top side, jump it over and connect it to that black wire there. That's bringing the hot in, shooting it down to the left three-way switch. So our common is the hot on that end. And then lastly, our switch loop going down to our light and going to the common screw on the right-hand side three-way. So that is fed at the light. Three-way switches controlling the light fixture. Power supply is at the light. Okay, now take a deep breath before we get into this one. This is D8. Now this has two three-way switches and two four-way switches controlling two light fixtures. The power supply and switch wires are at the first light. So everything's kind of coming in there at the very first light at the top side there. And then we have two three-way switches and two four-way switches. Now notice, just for reference here, three-way switches are always on each end of the switching system. The four-way switches go in between. So you'll always have two three-way switches, one at each end, and then you could have as many four-way switches in the middle as you want. So we're going to go ahead and get our grounding done. to connect to the box. And then we're going to connect the ground conductor so it feeds on through. We got to bond this box also. Bring it around to there. And we get to our switch. Connect to our box, connect to our device, and continue the feed on through. And then down here on the bottom side on the 4-way, do the same thing. Connect to the box. And then in this box, we are connecting to the box, to the feed through, and to the device. And then lastly, on the very last box here, we connect to the box and to our ground screw on the device. Now, let's do our neutrals. So, starting at the top, neutrals go to our neutral terminal, the silver terminal, chrome terminal. And then that neutral has to feed on through into the next box and feed up to the next neutral terminal. You have 2 lights on this one now, not just 1. That's pretty much the end on the neutrals. That gets them done. So next we are going to go to the red conductor. And we're going to do something very unusual on this one. We're going to connect the red conductor up here to the hot terminal on the light. The next box over, we're going to do the same thing. Now, we have a color change here, which is highly unusual. But we're going to change this. We're going to use this blue wire here to connect to the light terminal. That means that blue wire is going to be our common down here in the 3-way switch. Now what we're going to do is we're going to bring this on around, come around and connect to that common right there. Okay? Now, what we have left up there in the light outlets are the black wires. So we've got to get a hot feed, a constant hot feed down into the switching system. So we'll connect those together, connect these on together through, which brings us down to here where we've already got our common taken care of this end. So we're going to just connect that black wire, feed it on through, come to the next box, it's going to feed on through. Next box, same thing here. Getting kind of crowded. And then all the way down here at the end, the black wire will end up being our common on the 3-way at the far end. This wiring scenario probably has the most complexity of all of them. And it's not really complex when you complete it, but you just have to kind of work your way through it and think each conductor through. The best way to wire these scenarios, first of all, is to go through, pull all the wires in just like the scenario looks, and then start making terminations. Okay, so now I am going to switch over to the red, and we're going to do our red travelers. And I'm going to have to bring this one all the way around and get it over to here. Again with this one, get it up there to the terminal, and then this one all the way up to the top here and get it into that terminal. So that gets all of my reds. And then the blues. So we only have one terminal left down here on this one, and that finishes that box. And then on the 4-way switch, the travelers feed in from the top to the bottom. So there we go there. Whoops. Wait a minute. I missed one, didn't I? Jump back over to my red for a second here. Got that one. Again, in these videos, at any time if you got to stop, draw onto your drawing so you're following along, feel free to do so. And there we have our travelers fed in from the top, out the bottom, and then the next 4-way switch fed in the top, out the bottom. I know it looks like a lot of chicken scratch, right? And then here's our last traveler. And I believe that's got them all. So this is 2 3-way switches and 2 4-way switches controlling 2 light fixtures. The power supply and switch wires are at the first light. Okay, down to the last 2. This one's fairly simple. This is going to be all standard duplex receptacles. So first of all, we're going to go through and do our grounding. Ground our box. Ground our device. And then come on, feed it through into the next box. And then, of course, into the next one. And then into the very last box. Okay, now, receptacles, just like light fixtures, have to have a neutral conductor or grounded conductor connecting to them for them to work. So, from our power supply, we're going to feed into the receptacle. Now, I'm going to draw that we are feeding in and out of each one of the terminals on the receptacle. That is code legal. Done mostly, at least in the region that I live in, done mostly this way in residential. In commercial, oftentimes, rather than using the terminals on the receptacle, they will actually tie the 2 neutrals together, or this could be the hots, and make a pigtail coming off of them and connect that one single wire to the receptacle, rather than having the device being used as a terminal point. And the reason they do that is that, let's say that I was working on a receptacle downstream from the main power supply, and or there was a piece of equipment connected downstream, and I was working on the main receptacle where the power supply comes in. If I disconnected the neutrals first by accident, I could actually damage equipment downstream. So if they're all connected together and pigtailed coming off of it, that means that you could less likely to do accidental damage to equipment that might be downstream in the circuit. Okay, so we only have black wires left. We're going to connect that at this end, connect that at this receptacle, and then feed in and out of this one. Feed in and out of this one, and that completes all of our receptacles. If we were going to bring them all together, and I'll just draw it up here, we would bring them together like this, tie everything together and make a pigtail off of them like that, and this is what would connect to the receptacle, just one single wire, rather than having 2 wires. All right, and the very last one is going to be a switched receptacle. Now, single post switch controlling a duplex receptacle. The power supply begins at the switch outlet, and the receptacle is half switched and half constant hot. The tab on the hot terminal side will have to be removed to separate power to each of the screw terminals. And if you look in our lab book, in the back of the book, it has a photo of a receptacle that has had this done to it. The terminal there on the hot side has to be augmented a bit by using a pair of needle nose and breaking the tab in between the 2 terminals off to where the top port of the receptacle is separate from the bottom, at least on the hot side of it. That's how you make these work. So what's going to happen here is you're going to be able to flip that switch on. The top outlet on the receptacle will be controlled by the switch. The bottom, we're going to wire it so it's constantly hot. And this could be used in a bedroom is oftentimes the scenario where you have a switch that you walk in and you've got a lamp plugged into the top part of the receptacle, so the lamp comes on and you can go over there, you get in bed, reach over and flip the switch on the lamp and turn it off, and then when you get up in the morning, turn it back on, and then as you're walking out of the room, you can hit the switch and turn the lamp off as you're leaving. Meanwhile, the bottom part of the receptacle is hot all the time, so you can plug in let's say you're charging your cell phone there by the bed. Often people do that. And that way that receptacle stays hot all the time because you don't want it operated by the switch. So that would be the scenario this would be used in, just one of many. So first of all, we get our grounding done. Bond the box, bond our switch, connect it to the supply, bond our box, bond our device. And now get over to our neutrals. And our power supply is coming from the switch, right? So we have to connect the neutral to the neutral going out to the receptacle, and then when it arrives at the receptacle, simply connect it to the chrome terminals, and that takes care of that. So our next conductor is going to be our red conductor. So our red conductor is going to be what we call a switch loop, and we're going to connect that to the terminal on the switch, and then we're going to connect it over here to the top terminal on the receptacle. That's really an industry standard. I've seen some folks that actually switch the bottom section. There's not a right way or wrong way, but nevertheless, the method we're going with is being on the top, and the bottom will be the constant hot. So that takes care of our reds. And lastly, our hot wire. Over here on the receptacle, we're going to connect our black to the bottom terminal. We've broken this tab off right here, and now that separates the top and the bottom. So now the only thing we have left is over here at the switch. We've got our power supply. Now we have to feed that power supply on through so we get a constant power supply at the receptacle, but we also have to pigtail off of that and run a hot over here to the switch so we have a constant power supply at the switch so we can turn the light on. All right, that is D10, single pole switch controlling the duplex receptacle. These are called, depends on probably what area of the country you're in. We call them half hots here where I am from. Switched receptacles, half switched receptacles, lots of different names for it, but essentially part of the receptacle is switched, part of it is hot all the time. We've also used these in receptacles underneath the sink in the kitchen where you have a circuit coming in that feeds the dishwasher and the disposal. The switch operates the top part of the receptacle to operate the disposal, and the bottom part is where you would connect the dishwasher. And that way the dishwasher has a constant supply. That's a scenario we use, at least in my area here, for wiring in a residential application. Okay, that is D1 through D10 of branch circuit wiring and switch control. Okay, so that takes us through D1 through D10 of the branch circuit wiring and switch control book. Those are the foundational wiring scenarios that will enable your students, or if you're the student, to move through all of the other scenarios throughout the book. Now it expands as it goes on and begins to create more and more complexities and multiple 3-ways and 4-ways in the box, GFCI protection, a whole nother subject, and even later on in the book gets into machine control relays. So this is the foundation you need to be able to build on to move on up into the other scenarios in the book. For instructors who may be checking out this video, basically in the book there is a sign-off sheet where after each one of those scenarios completed, your student can actually receive credit, is how I typically do it, and you can sign off that they completed it, test it, and then they sign off on it. And there are a total of 50 scenarios throughout the book. So once they've gotten through these 10, there's another 50 they can work through to really hone those hands-on skills. So when they get through with your course, they don't just know how to maybe do it. They did a 3-way switch once, they did a 4-way switch once, and a year from now when somebody asks them to do it, they don't even remember how they did it. When they get done with this book, they're going to know how to do it. So be sure and check out some of our other publications and visit our website at electriclab.org. My name is Mike Barley, and thanks for watching.